Welcome to this WiseOwl Excel VBA tutorial. In this video we'll look at how to get data from a SQL Server database using ActiveX Data Objects record sets. We'll start with a quick reminder of how to reference the ActiveX Data Objects library, and then we'll use that to connect to a SQL Server database. We'll then get data from a SQL Server table into an ADO record set, and then write the data from the record set into an Excel worksheet. We'll quickly cover an annoying bug/feature that I discovered recently while delivering a training course, and then when we've got that out of the way, we'll look at how we can expand our routine to include the column headings in our output worksheet. Then we'll look at a couple of different techniques for getting data from SQL Server. We'll look at writing SQL select statements in your VBA code, referencing a SQL Server view, and then finally how to call a basic SQL Server stored procedure. So quite a lot to do in this one. Let's get started. Okay, to get started you'll need several different things. First of all, a copy of the files I've prepared for this video. I'll pop a link in the video description so that you can download this folder, and when you've extracted that you'll find 3 separate SQL script files. You will of course need an instance of SQL Server available to execute these scripts against, and if you haven't done that already, you could follow along with one of our video tutorials which explains how to install a free developer edition of either SQL Server 2017 or SQL Server 2016 if you prefer. We're going to be connecting to our instance of SQL Server using the latest version of Microsoft's OLEDB driver for SQL Server, and that's something you'll need to download and install separately. If you followed along with a previous video, you've probably already done that. So assuming you've got to that stage and everything's installed, you'll then need to open up SQL Server Management Studio in order to start executing these SQL scripts. If you've installed it already, you should find you've got a shortcut in your Start menu. I've created a quick shortcut pinned to my Start menu for SQL Server Management Studio 18. I've actually already opened up that application and connected to my local instance of SQL Server 2017. I've called it SQL 2017 Training. The first thing I'm going to do in here is open up my script that will create the movies database. You may already have done that from previous videos, but for now I'm going to choose to open up an existing file and then point to that folder on my desktop and open up file number 1, create movies database. When the file's open, I'll just click the execute button to execute the script, and it shouldn't take too long. It's not an enormous database, but eventually we'll get a set of results indicating that something has happened, query executed successfully. And if I look in my databases folder, I might need to refresh that folder to see that the movies database has appeared. I can do that by right-clicking databases and then choosing the refresh option. And there's my movies database available. What you'll then need is a blank Excel workbook, which I've created here, and from there we can head into the Developer tab, open up the Visual Basic Editor, insert a new module into the project, and we're ready to start writing some code to connect to our WiseOwl Movies database. We'll start writing the code by creating a subroutine called Get Data from SQL Server. And when we've done that, just to give us a helping hand with the IntelliSense, we'll set a reference to the Microsoft ActiveX Data Objects library. So if we head to Tools References, and then when the dialog box appears, scroll down through the list to find Microsoft ActiveX Data Objects, and then just check the box next to the latest version you have available. It should be 6.1. If I check that box and then click OK. We'll then immediately use a class defined in that library. We'll declare a variable, which I'll call CN, which can hold a reference to an ADODB.connection object. We'll then need to create a new instance of the connection class, so we can say set CN equals new ADODB.connection. And then we can set the connection string property of that connection to provide all sorts of information. So we can say cn.connectionString equals. Now we dealt with connection strings in quite a lot of detail in the previous video, so I'll just go over this relatively quickly and I'll write this across multiple different lines. We'll start by specifying the name of the provider we want to use to connect to SQL Server, so provider equals. Now as I said, we're going to be using the latest version of Microsoft's OLEDB driver for SQL Server, and to specify the name of that we need to say MS OLEDB SQL. The previous video, as I say, talks in a bit more detail about different providers and connection strings, so feel free to refer back to that if you're not using the latest version of this driver. We'll end that part of the connection string by typing in a semicolon, and then I'll concatenate that using the new line character to specify the server name. Now the server is, in my case, on my local machine. So I can type this in a variety of ways. I can say localhost, or I can just shortcut that to a full stop, followed by a backslash, and then the name of the actual instance of SQL Server. If I quickly switch back to SQL Server Management Studio, you can see up at the top there, it's SQL 2017 Training. If I enter that name, SQL 2017 Training, follow that with a semicolon and then close the double quotes, and then I can concatenate to the next part of the connection string using the new line character again. The next thing we'll do is we'll specify which database we're using, so that's fairly easy. The one we've just installed is called Movies, and then again a semicolon to end that part of the connection string, and then concatenate that using another new line character. And then finally we're going to say that the trusted connection property is yes. So trusted connection equals yes. That indicates that I'm using my Windows credentials to connect to my instance of SQL Server. And if you installed your instance of SQL Server following along with our video, your server will be configured using Windows authentication as well. So Windows authentication, close the semicolon followed by the double quotes, and then that's the connection string created. What we should just then do is test that the connection is actually set correctly. So we can say cn.open and then give ourselves a few blank lines and say cn.close. And if we use the F8 key just to step through this subroutine at this point, when we hit cn.open, if nothing appears to happen, then that's a really good sign. If something happens, it indicates something's gone wrong. So we can open the connection and then close the connection and then end the subroutine, and that's our connection established. Now that we've established a connection to the database, we can grab some data from it using a record set object. Let's declare a new variable. I'll call mine rs as adodb.recordset. After opening the connection, we can create a new instance of the record set class by saying setRs equals new adodb.recordset. Then there's a couple of different approaches to loading the record set full of data and then grabbing it out into Excel. So one technique is just simply to say rs.open and then type in a space after the name of the open method and fill in all the various parameters to configure that record set. So there's a source, an active connection, a cursor type, a lock type, and an options parameter. I find it gets a bit messy if you try to do all that in one single statement. So rather than just opening the record set immediately, what I tend to do is say rs dot and then set the various properties individually. So you'll see that all of those parameters for the open method all have their own separate properties. So here's active connection. I can say rs dot active connection equals, and then we only have one connection available, so it's a fairly easy choice here. It's equal to cn. The next thing we'll do is set the record set source. So we can say rs.source equals, and then pass in a string which indicates the set of data that we want to open up into the record set. Now this can be a variety of things, as you'll see as we go through this video, but just for now what I'm going to do is just refer to the name of a table which exists in our movies database. If I just switch back quickly to SQL Server Management Studio and then expand the Movies database and expand the Tables folder, we'll see a list of the table names in the folder there. So I'm going to go with the first table in that list, dbo.actor. dbo is the name of the schema that the act table belongs to. It's not actually necessary to provide that, but just for being as explicit as possible, I'm going to say dbo.actor in my VBA code. So we can say dbo.actor. And then once again at this point we can choose to open up the record set by saying rs.open, and then we should test that it opens by running the code, but before we do that let's add in rs.close as well. So if I use the F8 key to step through now, we've got our connection open as usual, and then we've got our new record set its active connection, set its source, and then choose to open it. And again, if you execute that instruction and nothing appears to happen, that's a really good sign. So I can carry on stepping through now to close the record set, close the connection, and then end the subroutine. Now you may have noticed when I showed you the parameter list for the open method that there were a few extra properties that we haven't yet set. If I type in a space after the open keyword, we specified the source and we specified the active connection, but we omitted the cursor type and the lock type. These obviously must have some kind of default value, otherwise the code wouldn't have worked at all. And the default option that's shown here in the open method is that it's unspecified. Now this works perfectly adequately for just simply reading some data from the database and then dumping it straight into an Excel worksheet. There isn't anything we actually need to do here to make this work. These extra options for cursor type and lock type are more important if you choose to modify data in the record set, something we'll get onto in a later video. If you are interested in the various options for cursor type and lock type, there is some documentation available, of course, on the Microsoft Docs website. So you've got the cursor type property, and it shows you the various options available for cursor type there. There's a separate page which shows you the list of options available for the cursor type and describes them in a little bit more detail. The fastest one available is AD Open Forward Only, which allows you to make one pass through the record set, and the data doesn't go back to the server to pick up any changes made by any other users of the database. So for best performance, AD Open Forward Only is the one to go for. The lock type is more to do with modifying data in the data set or in the record set once it's been loaded. So if you wanted to use your VBA code to either update information in the database or delete records or add new ones, you'd need to set a lock type which allowed that. The quickest one to use, and the one we need for this example, is AD Lock Read Only. We don't care about modifying any data at all. So if we wanted to be a little more specific, we could indicate that in our VBA code. Bear in mind, as we've just seen, it's not actually necessary. But before we open the record set, we could say rs.cursorType equals, and then say AD Open Forward Only. And we can say rs.LockType equals AD Lock Read Only. And again, just to demonstrate that this will work, let's use the F8 key to step through the procedure and make sure that we can open the record set successfully with nothing appearing to happen, and then close the record set, close the connection, and then end the subroutine. Now I'd like to look at how to get the data out of the record set and write it into an Excel worksheet. That doesn't happen simply by opening up the record set. If you look back at Excel, of course, you'll see that sheet 1 is still completely empty. So there are several techniques you can use to get data out of a record set, but a really quick, simple, easy, convenient way is to use a method of a range object in Excel. So if we assume that sheet 1 will be active when we run this code, what we could do is refer to range A1 and then refer to the copy from record set method. The copy from record set method requires a reference to a record set. The first parameter there says data as unknown, and the reason it says unknown, I might have mentioned this in the previous video, is that the record set class is defined in the ActiveX data objects library, whereas the copy from record set method is defined in the Excel library. So because the Excel library doesn't know anything about the ADODB library until you reference it, it has to say unknown here. It can't say record set because it doesn't know what that is. Anyway, long story short, just refer to the record set you've created and opened, and then that will use cell A1 as the top left-hand corner of a table into which to paste all the data from the record set. So at this point, if I simply hit the Run button and then switch back to Excel, you'll see now that it's absolutely full of data from the record set that we loaded. So a list of all the actors, their dates of births and their genders and their ID numbers as well. Just before we move on and talk about some more interesting things we can do with the extracted data, I want to mention quickly a bug or a feature, I'm not sure which, that I encountered while delivering a training course recently. So what I'm going to do is I'm going to go back to my code, and rather than paste the data from the record set into sheet 1 every single time, I'm going to write a line of code that adds a brand new worksheet. So immediately before copying from the record set, I'm going to say worksheets.add. Now you'll probably know that doing that automatically inserts a new worksheet and then makes that worksheet the active sheet. You'll have seen that in previous videos. Now watch what happens if I hit the F5 key to run this one all the way through from start to finish, and I switch back to Excel. I've got my same data in here, but you might notice that this time the date format, what should be the date of birth and date of death for the actors, is just shown as the raw underlying number rather than the lovely date format that we showed earlier on. Now, if I do this again, if I go back to the code and run it again, and then look back at Excel, you'll see again the new version, sheet 3, has the numeric data. If I go back to sheet 2, suddenly that's all been formatted as a date. It gets even worse if you have a non-worksheet object selected when you attempt to do this. So what I'm going to do, it doesn't really matter what data you have selected here. I've got cell A1 selected with a number in it. I'm going to insert a chart. So if I press the F11 key on my keyboard while in Excel, with a number selected, it will try to create a chart for the data that's selected. It's completely nonsensical. The data I had selected doesn't make a good chart. That's not the point. I want to run this code while I have a chart selected. So if I go back to the VB editor and then I run the subroutine again, now I get a runtime error, which is really annoying. If I switch back to Excel, however, look, the code is finished. The code's pasted the data from the record set into a brand new worksheet. It has succeeded, but the runtime error message is telling me that the copy from record set method has failed. What on earth is going on? I genuinely don't know why this is a factor. I'm sure this is a bug. I did have a search for other people who might have encountered this, and I only found one other person on Stack Overflow who described the exact same problem with the same setup, Office 365 and Excel 2016. Mr. Peter B, he didn't receive a sensible answer, sadly, so Peter B is as in the dark as I am about this. Anyway, there's a really simple solution to this, one that prevents this problem occurring in the first place. It's not something you should have to do. If I switch back to the code, after adding the new worksheet, what I want to do is select the worksheet that has just been created. So even though it is already the active sheet, I need to either activate or select it to make it work. So I'm going to say active sheet dot either activate or select, it doesn't really matter. Which is something you should never have to do. But if I run the subroutine again this time, let's see, what do I have selected at this point? Let's run it with a worksheet selected first. If I run that one and then look back at my code, now I can see that my new worksheet, sheet 5, has got the dates formatted correctly. And then if I select a chart sheet and then run the code again, I should now find that I don't get a runtime error, and the end result is a new worksheet, sheet 6, with the dates formatted correctly as well. So that might not affect you, but it's worthwhile pointing this out so that it avoids confusing you if you ever do encounter it in the wild. Okay, at this point I'm just going to do a quick bit of tidying up. So I'm going to select all the sheets that I've created using my code, except for sheet 1, the one that originally existed, and then right click and choose to delete them. And then when I've done that, I'm going to head back to the Visual Basic editor, and we're going to be running several different tests for getting data from various different record set sources. So rather than have all the code for creating the new worksheet within the same subroutine, we're going to extract this and place it into a new subroutine. So let's head up to the top of the module, and I'm going to create a new sub called write data to worksheet. And we're going to give this subroutine a parameter. We're going to call it, let's call it result set as adodb.recordset. Then if I head back to the code where I was creating my new worksheet and I just get rid of all that, I'm going to replace that little section there with a call to my write data to worksheet, and we're going to pass into it the reference to our record set variable. Now that we've done that, we can head back up to the write data to worksheet method, and we can add in the bit of basic code we need to create a new worksheet. So let's do a couple of things here. Let's declare a variable called ws as a worksheet. And then I'm going to set ws to be equal to worksheets.add. So we'll both create a new worksheet and return a reference to it at the same time. Then I'm going to make sure that I've selected or activated that worksheet by saying ws.select. And then I'm going to refer to range A2 this time. And then when I've referred to range A2, I'm going to use the same copy from record set method, and I'm going to refer to my result set parameter. So I can say result set. Okay, so having done all that, let's just quickly test that this works, just to make sure we get the same set of results. So I'll go back to the get data from SQL Server routine, and I'll run that one, and I ought to end up with a new worksheet. And this new worksheet should have the same set of data, but starting in row 2 this time rather than in row 1, and it should have the dates formatted correctly. Now let's look at how we can get the column headers written out into the top row of our output worksheet. It would be kind of nice if there was a simple property called maybe include column headers that we could set to be equal to true, but sadly that's not the case. We have to do things the difficult way, and the basic approach to this is to loop through the fields collection of the record set and then write out the name property of each field into the top row of the output. Now, this is another part of ADO that I think has gone a little bit wrong. There should be a field class available in the ADO object library. If I have a quick look at the documentation here, look, we have a fields collection which belongs to a record set object. So it contains a list of all the field objects. So there's a separate piece of documentation which describes the individual field object. The relationship here is the same as worksheet to worksheets or workbook to workbooks, etc. So the field object, the field class, is defined and documented clearly in the Microsoft Docs website. However, if we switch back to our VBA code and go back to our write data to worksheet method, if I wanted to loop through a fields collection, I'd need a variable which holds a reference to an individual field object. So I'd probably say something like dimf as field or ADODB field as it's defined in that library. But if I look for the field class, annoyingly, it doesn't appear. So what's going on here? This is a problem that I haven't found a solution to. I can show you what I think is going on. If I view the object browser, having set a reference to the ADODB object library, we can view that library separately by selecting it from the drop-down list at the top. And you can clearly see in the list of classes on the left-hand side here, there's no entry for the field class. Okay, so if I were to right-click somewhere in the background of the object browser and choose to show hidden members, what I do see, if I scroll down to the place where the field class should be, is a deprecated or hidden member. Look, so I've got field grayed out here and I've got fields grayed out here as well. I genuinely don't know if this is a mistake or whether Microsoft intended to do this. I can't find any indication that they intended to deprecate the field class. They tend to indicate deprecated versions of classes with the actual word deprecated. I think this is possibly a mistake. I think when the library was released, they accidentally hid the field and fields classes. But regardless, whether you want to hide the fields hide these members or not, if you have them unhidden, when I go back to the module and say dimf as adodb.field, you will see that it now appears in the list. But annoyingly, it messes up the list with all the other hidden members as well. I don't particularly like that, so what I would prefer to do is keep the hidden members hidden. So if I go back to the object browser again and then right click and uncheck the show hidden members option, I'm happy that the field class exists. Its definition is in the library, so I can still reference the field class. So I can say dimf as field. I just don't get the IntelliSense for the class name appearing when I declare the variable. I'll hit the escape key just to avoid accidentally selecting an item from the IntelliSense. And then after I've selected my new worksheet, what I can do is say for each f in result set dot fields. So we'll see the fields property exists for a record set, which returns a reference to the fields collection containing a collection of field objects. It's just that the class names themselves don't appear in the IntelliSense. I've just realized I should. It's not actually necessary, but I should, in this case, disambiguate my reference here to make sure I am referencing the ADODB field rather than a field defined in any other library. Sorry, anyway, I've got my for each f in result set.fields line. I can give myself a couple of blank lines here and then say next f to move on to the next item in the collection. And then having selected a worksheet, I'll know that the cell I have selected to begin with is range A1. So I can approach this in a couple of ways. I could write out the field name in the active cell and then physically move to the next column in the worksheet. But selecting cells is a little unnecessary. A simpler approach would be to declare a variable which keeps track of the count of fields. So I'm going to say dim I as integer. Then I'm going to write a statement inside my for each loop which says I equals I plus 1. So integer variables are initialized to 0, so the first thing that will happen inside the loop is that I will become 1. I'm then going to use the cells property of my worksheet. I'm going to say ws.cells, open some parentheses, and then set the row number to be equal to row number 1 and the column index to be equal to the value of I. I can then say .value equals, and then finally I can say f.name. So although the class itself isn't referenced in the IntelliSense or isn't shown in the IntelliSense, I do get access to all the properties of the field class and methods of the field class. It's all just a little bit bizarre. Anyway, that will loop through the fields collection, write out the field names in the top row of our output. So once again, let's just quickly test this by heading back to the get data from SQL Server subroutine and then run the subroutine, have a look at the results, and now we get the column names written out. As always in VBA, there are many ways to achieve the exact same end results, and if it bothered you that the field class doesn't appear in the IntelliSense and you want to avoid using it entirely, you could have written this loop in a slightly different way. If I switch back to the Visual Basic Editor, and if I get rid of my field variable, and then just comment out my for each loop for the time being, we could have just written a simple for next loop to loop through the fields collection of the result set. So for example, we could say for I equals 0 to result set dot fields dot count minus 1. The fields collection in ADO is indexed from 0, unlike most Excel VBA collections which are indexed from 1. So we have to sort of offset the count to start from 0 and then end at 1 less than the number of items in the collection. Then I can say next I to move on to the next iteration of the loop automatically, and then I can simply say ws.cells and then refer to row number 1 and then column number I plus 1. So again, I'm beginning my loop at 0 rather than 1, so I must add 1 to it, otherwise column 0 doesn't exist. And then I can say .value equals, and then result set .fields, and then open some parentheses, refer to the value of I, and then say .name. So that's a little more abstract, I appreciate, and it's annoying to have to offset the count and the loop counter and the count of fields. But it avoids having to declare a variable which essentially uses a non-listed class in the IntelliSense. Just to demonstrate that it gives you the same results, let's run the subroutine, the get data from SQL Server subroutine, and if we look at the results, we'll end up with the same column names listed out again at the top. And if I switch back to the Visual Basic Editor, it's entirely up to you which of these techniques you use. I will admit, I tend to prefer for each loops here. So for this example, I'm just going to delete the for next loop. I'm going to uncomment my for each loop and then uncomment my field variable. And that's what we'll stick to for the rest of the video. There are just a couple of extra bits of tidying up I'd like to perform in the write data to worksheet method, and I can demonstrate this, I think, by changing the table name I want to select from. So if I head back to my get data from SQL Server method, I can change the source so that I'm looking for the film table this time. This one's got quite a lot of data in it and a little bit more expansive than the actor table. So having changed the source to the film table, when I run the subroutine this time, I'll get a new worksheet, and you can hopefully see what's going on here. That some of the column names, some of the titles of the films are quite long and the columns aren't wide enough to display them. And some other values in the review column, for example, have text wrapping enabled. I think this is to do with having copied and pasted this from where I copied and pasted it from. So I want to avoid the ridiculously tall rows as well. So what we'll do is, if I just delete all these extra worksheets for now, and then head back to the VB editor, and I'm going to go back up to my write data to worksheet routine, and then having written out the column headings and having copied all the data from the record set, I'm going to refer to range A1, the top left hand corner of the result set, and then I'm going to refer to the current region property, which essentially refers to the range everything up to the next completely blank row and blank column. And then I'm going to refer to the entire column property and then apply the auto fit method to that. So that will change all the column widths to be the right width for the data. I could also then choose to stop the text from wrapping. Now, if I do that after I've changed the column widths, the columns won't be wide enough to read the entire review. So I might choose to do that before I auto fit the columns. I can say again, range a1.currentRegion dot wrap text equals false. So having done that, if I run my get data from SQL Server subroutine again, and then have a look back at Excel, I can now see that the column widths are all the correct width for the data contained within them. That makes for some quite long column widths for the review column, but you can see there that everything else is set to be a sensible width to display all the data. Now let's start looking at some more interesting ways to set the source for our record set. If I switch back to the Visual Basic Editor, I'm going to make a change to the way the sub get data from SQL Server works. Rather than continually modifying this line somewhere in the middle of the subroutine, I'm going to provide a parameter for this particular subroutine. So let's call this something like, let's call it source text as string. Then what I'm going to do is modify this line one final time. So rs.source equals, then I'm going to refer to my source text parameter. What I'm then going to do is write another subroutine below this one, basically as a test routine. I'll give myself a few blank lines. So I'll say sub test SQL queries or SQL data, something like that. And in here, what I can do is say get data from SQL Server. And then I can pass in the name of the table or any other string of text that would legitimately get something from that database. So let's just very quickly check this one more time. If I say dbo dot, let's go for the director table this time. And if I do that, having open and closed the double quotes, when I run this subroutine now, it will give me a new worksheet containing a list of all of the directors in the direct table. Now let's look at how we can write a SQL Server select statement to return a different set of data from our database. So rather than writing a table name which just returns all of the columns and all of the rows from the table, we can write a select statement to limit the rows and columns we return. Now, writing select statements is an art in and of itself, and we do have a separate video tutorial which explains how to write from basic queries all the way through some quite complex options for writing select statements. So we're not going to go into quite as much detail because, well, of course that tutorial already exists for that purpose. But some simple things we could do. Let's just remove the DBO director statement, and let's begin by writing the select keyword. Now, SQL query text isn't case sensitive, but it's common practice, or at least it used to be common practice, to write SQL keywords in all caps, just to help distinguish the keywords from the other parts of your query. So let's say I wanted to refer to a few specific columns from my film table. Let's say I wanted to get the title column, followed by a comma, and then the release date column, followed by another comma, and then the runtime minutes column, and then one more, we'll have the Oscar wins. If you're not sure what column names you have available, then you can use the SQL Server Management Studio application to help. So if I look at the list of tables in my database, and then I find the film table, I can click the plus symbol next to that, and then I can expand the columns folder, and that will give me a list of the column names from that table. So I've gone for title, release date, runtime minutes, and Oscar wins. I also need to tell the query or the select statement which table to get those columns from. So if I say from and then say dbo.film, and again the dbo part is optional, but it's good practice to be as explicit as possible. And then at that point, if I simply run this test SQL queries routine at this point, and then have a look at the results, I've now got a limited set of columns containing just the data I want. So I can avoid selecting the review column, for example, and all of the other ID columns that aren't interesting at this point. I could also choose to sort the results of my query by applying the order by clause to the select statement. So for example, should I want to sort the query results so that the one with the most Oscars appears at the top of the list, the winningest film as it were, we could apply the order by clause to the Oscar wins column. Let's head back to the Visual Basic Editor, and then I'm just going to break this onto a couple of different lines to make it readable. Let's do as we did earlier, where we with the connection string, I've got my select list here, and if I leave a space at the end of the list of columns, I can split this and concatenate the from clause onto the next line. And then again, if I leave a space after the name of the table, I can concatenate another new line, and then I can begin this line by saying order by, and then I want to refer to the Oscar wins column. It isn't actually important that the Oscar wins column is in the select list. I can order by any column that is in the table referred to in the from clause. So if I say order by Oscar wins, by default, Oscar wins will be sorted in ascending order, so the most Oscar wins would appear at the bottom of my list. I want to sort it in descending order, so I must specify DESC. And then if I close the double quotes at that point and then run the query again, or run the subroutine again, I should say, when I look back at the results this time, the 3 winningest films, as it turns out, are at the top of my list. You can apply a sort order to multiple columns in the same query. So for example, should I want to change the order of this list so that the earliest film with the same number of Oscar wins appears at the top of the list, I could extend my order by clause. If I switch back to the Visual Basic Editor, I can simply write a comma-separated list of columns I want to order by. So I've got order by Oscar wins descending, followed by a comma, and then I can say release date. Now the default sort order is ascending, but if I wanted to be explicit, I can say ASC to indicate that that's what I intended to do. So once again, having modified that, I can run the subroutine again, and I'll end up with a new worksheet, this time with Ben-Hur at the top of the list, followed by Titanic, and then Lord of the Rings. So in descending order of Oscars, and then ascending order of release date. Another incredibly useful thing I can do is apply criteria to the query to eliminate results that I don't want. So for example, if I just quickly scroll down to the bottom of this list of Oscar wins, if I press Control and the down arrow key to jump down to the bottom, there are many films with absolutely no Oscar wins, and I don't want those films in my result set at all. Bear in mind some of this data might be a little bit out of date. This database was created in 2016 and it's 3 years since then. So if I scroll back up to the top of that list, let's remove some of the non-Oscar winners by applying a where clause to the query. So if I switch back to the Visual Basic Editor, the where clause sits in between the from and the order by clause. The order of the keywords in a select statement are very important. So it's select from where order by. So I'm going to need to insert a new line in between these existing ones, which will cause a bit of a mess to begin with. But if I then do indeed include the where clause, and then I can say where Oscar wins, and I can simply say greater than 0. And then if I leave a space and then close the double quotes and then concatenate that with a new line character, a space and an underscore, this time when I run the subroutine again, I'll get yet another worksheet. And if I look back at Excel, I'll see if I scroll down to the bottom of column D this time, I end up with the last film in my list which won 1 Oscar. Again, I can include multiple criteria in my where clause, and if I wanted to do that, let's say for example I only wanted to show films that were at least 3 hours long and won at least 1 Oscar. For example, if I switch back to the Visual Basic Editor, I can extend my where clause by using logical operators such as and or. So I've asked where the Oscar wins is greater than 0, and run time minutes is greater than or equal to 180. Having done that, if I run the subroutine again and then look at the results, this time I should have a much shorter list, clearly showing that the criteria are working. So this is all quite cool and fairly powerful as well, and you'll get an idea as to how far you can take this with some of the videos in the SQL Server series. But if you have the same query to write time after time after time, if you were always interested in a common set of results and you didn't want to have to continually write out this same query in your VBA code, it is possible to store queries effectively in a couple of different ways in your SQL Server database. So what we're going to do next is have a look at how you can create something called a view in a SQL Server database. A view is essentially a saved select statement which is executed when you call on the view. So I've got a little script that I've written already that we can execute to create this. If we switch back to SQL Server Management Studio, and then I'm just going to close down the script that I opened earlier on, and then I'm just going to collapse the columns and the film table and the tables list. you'll see there's a separate folder for views. If I quickly expand that, there's nothing in there at this point bar the default system views folder. If I then choose to open up another existing file and point back to the same folder that I was looking at earlier and open up script number 2, create Oscar winners view. If I double click that to open it up, it's kind of like an extended version of the select statement we were just writing together. So I've got the select list, which includes many columns this time. The from clause is a lot bigger as well. This one actually takes tables from multiple parts of the database, so it joins together multiple tables so that I can select columns and fields from those multiple tables. The where clause is a little simpler. It's just for the Oscar wins greater than or equal to 1. And there's no order by clause in here at all. The reason there's no order by clause is because it doesn't work properly in a view. It isn't intended to. The idea is that you select stuff from a view and then apply the order by clause to the results. Anyway, what I'm going to do here is just execute this script to create my new view. I'll get a little message saying commands completed successfully. And then if I just refresh my views folder, I can see that I've got my Oscar winners view sitting in there. So a really simple example of how to use that, if I switch back to the Visual Basic Editor, if I just comment out all the code I've just written there and then make another call to get data from SQL Server, but this time I'll just say dbo dot, I've already forgotten the name of my view. If I just quickly switch back to SQL Server Management Studio, Oscar winners view, let's just copy that from the create view statement. So dbo dot Oscar winners view. Having done that, now if I simply run this subroutine and have a look back at the results in Excel, there we go, I've got the results of my view written out automatically into a new worksheet. I'm just going to tidy up the workbook again a little bit by deleting all the worksheets except for sheet 1, so I can highlight all of those and then right click and delete. I'm starting to wish I'd written a procedure to do this, as I have in previous videos. Anyway, never mind. And then what I'd like to do at this point is show you how you could sort the results of a view. So one of the downsides to a view is that you can't, although you can write the code to order the results of a view within the view's definition, it doesn't actually work. So it's a bit pointless. So if I wanted to sort the results of my view, I'd have to treat the view essentially like a table in a select statement. So what I can do here is just modify this code to say select, and then I want to select every single column from the view. Now the most convenient way to do that is to just use the asterisk, the star, as a placeholder to essentially mean every column from. Now, something that some DB admins will turn their nose up at and say, oh, no, you shouldn't do that. And agreed, in many cases, this is a bad thing to do. If you're not sure if the definition of your view is going to change and you're always selecting everything, how can you possibly know how many columns and how many rows of data it's going to return? You might put such a big load on the server that it prevents other people from doing their jobs. So in the real world, avoid select star from. But in this case, as I created the view and I know that I'm not going to change its definition, at this point I'm happy saying select star from dbo.Oscar winners view, and then we can just add in the order by clause to the end. So excuse me, I just added in an extra space there. Order by, let's go with title. Let's sort it in ascending order of title. So order by title ASC. So at that point I can run the subroutine again and then have a quick look back at the results. And there we go, the same list of results from the view, but sorted alphabetically by film name. The final technique I'll cover in this video is how to use a stored procedure to return a set of results. You can think of a stored procedure as kind of like the SQL Server equivalent of a VBA subroutine. It's a program stored in the database. It can include variables and conditional statements and loops. It can be parameterized, and you can also get it to return sets of data, which we can capture in a record set in our VBA code. So let's switch back to the SQL Server Management Studio application, and then we can close down the script to create Oscar winners view. And then we can choose to open up another existing script. So we can open file and then open up file number 3, create Oscar winners procedure. If I double click to open that, it looks a lot like the script I used to create the view. So you can see it's the same select statement with the same from clause and the same where clause. I've included the order by clause here as well, ordering by Oscar wins and release date. The big difference here is that the stored procedure could do an awful lot more than the view. It doesn't really demonstrate, this simple example doesn't demonstrate how much more powerful stored procedures are compared to views, but we will hopefully see that in later parts of this series. If you're interested in how stored procedures work and the sort of the power you can get out of them, again, we do have an entire tutorial all about SQL Server procedures and programming, which you can have a quick play around with if you like. So it includes stuff to do with how you parameterize them and so on. Anyway, back to the point. If I simply run this script to create my new stored procedure, it should say commands completed successfully. You will find your stored procedure name in the wonderfully named programmability folder of your SQL Server Management Studio application. So programmability, stored procedures, and I should find my get Oscar winners procedure sitting there. So I'm just going to copy the name of that so that I know which one I want to execute, and then I can go back to the Visual Basic Editor, and then I'll just comment out the previous get data from SQL Server method call and replace it with a new one, get data from SQL Server. I'll then pass in the name of my stored procedure, so I can say dbo dot and then pass in my stored procedure name. I'll just paste that and then close the double quotes and then execute my subroutine to find, if I switch back to Excel, yet again another set of results from my SQL Server database. Okay, so there we go. We've seen 4 different techniques for getting results from a SQL Server database into an Excel worksheet. We've looked at referring to a simple table name, we've written our own basic select statements in our VBA procedures, we've referred to a view in the SQL Server database, and we've also executed a stored procedure and captured its results. There's plenty more we can do with this, of course, and we'll investigate some of the more complex ideas in later videos, but that should be enough food for thought for now. Hopefully you've enjoyed that one. Thanks for watching. See you next time.